Introduction to electric vehicle charging piles. The function of the charging pile is similar to that of a gas dispenser in a gas station. It can be fixed on the ground or wall and installed in public buildings, shopping malls, public parking lots, etc., and residential parking lots or charging stations. It can be installed according to different conditions. Voltage levels for charging various models of electric vehicles. The input end of the charging pile is directly connected to the AC power grid, and the output end is equipped with a charging plug for charging electric vehicles. Charging piles generally provide two charging methods: regular charging and fast charging. The human-computer interaction system can be used to perform a series of interface operations such as the corresponding charging method, charging time, and charging degree. The charging pile display screen can display data such as charging amount, cost, and charging time. According to the standard NB/T33008.2-2013, the following immunity tests can be performed on the materials: surge, impact, immunity test, electrostatic discharge immunity test, electrical fast, transient burst immunity test. Since the power system of electric vehicles is a DC system, during AC charging, the AC power cannot directly charge the power battery. It needs to go through a component called an onboard charger to convert AC to DC and convert it into DC according to the command of the BMS. After pressing, it is provided to the power battery. It consists of two core components, an AC, DC rectifier, and a DC/DC transformer. The former converts alternating current into direct current, and the latter adjusts the voltage of the direct current and then outputs it to the power battery of the electric vehicle. The onboard charger dynamically adjusts the charging current and voltage according to the commands of the BMS to adapt to the charging needs of the power battery at different stages. For example, during constant current charging, as the battery power increases, the charging voltage also needs to increase. During DC charging, the DC pile itself is an AC, DC rectifier, and DC/DC transformer, which can directly convert AC power to DC power outside the vehicle according to the needs of the BMS, replacing the role of the onboard charger. Therefore, DC charging is also called a non-vehicle charger. Charging method: a dedicated power supply device that uses conduction to provide AC power to electric vehicles with onboard charging devices. According to IEC 61851.1, GBT 18487.1-2015, Electric Vehicle Conduction System Part 1. General Requirements: Intelligent Control for the Design and Production of GBT 20234.1-2015, Connecting Devices for Conductive Charging of Electric Vehicles, Part 1. General Requirements, and GBT 20234.2-2015, Connecting Devices for Conductive Charging of Electric Vehicles, Part 2. AC Charging Interface, Motherboard. The ACP620 electric pile control mainboard displays the charging status by communicating with the LCD screen and completes the measurement of electric energy by querying the electric energy meter or metering chip during the charging process. At the same time, the intelligent control motherboard will actively detect faults in various parts, make immediate judgments, and take corresponding actions when a fault occurs. AC charging pile motherboard example: AC220V/14 kW dual gun car AC charging intelligent motherboard. Main control board power conversion module. Materials that can be used: varistor, TVS diode. Warranties components: varistor 20D561K,
TVS SMBG7 0K SMBG 20K,
diode 1N4148.
Integrated circuit chip.
Materials that can be used: Zener diodes, diodes. Warranties components: diode 1N4148, ESD 3V 3D 3B. External interface module. Replaceable materials: TVS array, field effect tube. Warranties components: SBRD tin, warranty tin 45-277. Generally speaking, the charging process of off-board DC charging piles is divided into 6 steps. In every complete charging cycle, the charger and the vehicle BMS, battery management system, monitor each other through frequent data interaction. In order to achieve normal charging, it is the so-called message communication, and the communication method uses CAN communication. The charging gun of the DC charging pile adopts a 9-pin male plug, which realizes the functions of DC power supply, DC+, DC, car, common grounding, PE, and message exchange communication, S+, S, car and pile connection confirmation communication, CC1, CC2, and low-voltage auxiliary power supply, A+, A. The DC charging piles on the market now use such charging guns to charge cars. According to the steps, press the gun head electronic lock without gun plugged in, insert the gun into the vehicle end, while the electronic lock remains pressed, release the electronic lock. At this time the gun is plugged into the vehicle end. The pile end detection point will detect 12V and 6V and 4V voltage changes respectively. When 4V is read, the pile end determines that the charging gun is successfully inserted at this time. The vehicle end is ready, and the electronic lock on the charging gun head is locked. The function of the electronic lock is to simulate and transmit back the gun plugging status, and lock the gun head to prevent it from falling off. After the charging handshake and charging parameter configuration are completed, the charging pile will control K3 and K4 to close and provide auxiliary power for the vehicle side battery control system. After the auxiliary power supply is turned on, the voltage value of detection point 2 is used to determine whether the vehicle and the pile are successfully connected. If the voltage is 6V, the vehicle side will continue to send handshake messages, and then close K1 and K2 to perform insulation detection on the pile side. The insulation detection is to check the insulation performance of the charging line to ensure the safety of the subsequent charging process. After the insulation test is completed, the pile side is put into the discharge circuit to release useless electrical energy, and K1 and K2 are disconnected at the same time. At this time, the vehicle and the pile send identification messages to each other to determine the necessary information of the battery and the charger. After that, the vehicle and the charging pile are configured with each other. The charger sends a message of the charger's maximum output capacity to the BMS, and the BMS determines whether charging is possible according to the charger's maximum output capacity. The vehicle side system controls K5 and K6 to close, and at this time, the charging circuit is partially turned on. If the charging pile detects that the battery voltage on the vehicle side is normal, the error between the obtained battery voltage value and the message description is less than or equal to 5%. Moreover, within the maximum and minimum voltage range of the charging pile output, K1 and K2 will be closed to turn on the charging circuit, and the electric vehicle will be ready to charge. The research and development complies with the requirements of the General Technical Specifications for Non-Onboard DC Chargers. The internal billing control unit modules of DC charging piles take DCP 3000L and DCP 1000L as examples. Taking this board as an example, the protection devices used are 12V power supply, varistor tin D180K, 2 way RS 485, TVS SMBJ 6.5CA, PPTC SMD 1812-012, 2 way CAN bus, ESD 24 VAPB, CAN protection, Ethernet port, gas discharge tube, GDT/SMD 1812-091, SLVU 2.8-4. The remaining interfaces are not obvious. The internal charge controller module of the DC charging pile takes CCE 1000HW as an example. Taking this board as an example, the protection devices used are ESD thermistor, gas discharge tube fuse. The main circuit of the DC charging module adopts rectification, high-frequency inverter, rectification, and filtering methods to convert power electricity into high-voltage DC. The primary main circuit control method uses input circuit breakers, contactors, and charging interface connectors to realize the shutdown and startup functions of each device. 2. The secondary main circuit mainly adopts the step-up and step-down method to form isolation from the primary side, which plays a role in preventing interference, DC, and AC isolation for the circuit. The DC charging module control circuit includes forced control consists of start-stop control and emergency stop control. Soft start control consists of operation monitoring control, charging pile intelligent controller, card reader, and human-computer interaction interface, in which the LCD human interface, the computer interaction interface, and the C card reader are collectively referred to as user terminal equipment, UT. The main circuit input circuit breaker has overload, short circuit, and leakage protection functions. The output contactor controls the on and off of the power supply. The connector provides a charging interface for connecting to the electric vehicle and has a locking device and anti-misoperation function. The secondary circuit provides start-stop, control, and emergency stop operation. The signal light provides standby, charging, and full status indication. The three-phase smart energy meter measures all electricity during the charging process. The user terminal provides card swiping billing, charging method setting, and start-stop control operations.